Hello and welcome back to part 12. This will be the last part. If you're seeing this screen and you've watched the previous 11 episodes on how to build a Frogger game or a Catter game, because we play with a cat, you're looking at this and say, that's dramatically different. In this video, I'm going to talk you through the changes that I made. I'm not going to show you how to build them. I'm just going to show you what I did, because the whole point of this is to build your Scratch skills and not to copy me. So here's what I did. Maybe the biggest thing you'll notice is up at the top I've got these 5 which I've called goal sprites in the 1981 Konami version of Frogger. There's little pockets where the lily pad shows up. In this one, little smiley faces show up on here. And we now have turtles. Turtles that dive underneath the water. And if you're riding on the turtle when it dives underwater, you're in big trouble. Your cat goes for a swim and, well, it dies. So let's play the game here and I'll show you some of the changes. So cat still moves normally. You'll notice the change here of this costume of this car and this car different. I didn't change any of the code. I just changed the costume to have them look different. In the previous version, the purple car was also here and the green car was there. So we have more logs, and the logs travel at a different speed. And so now I have these turtles here that you can ride on. So if you're on the next one, hopefully the turtles will dive down and I'll show you the cat dies if you're riding on the turtles when they sink in the water. See that? Which makes perfect sense. If a turtle sinks under the water, dives under the water, and you're a cat, you're gonna get wet. Everyone knows that cats die when they get wet. So riding on the logs and then the cat dies. All right. And so we also have, if we go all the way up to the top, you get on there, you can see that this fairly horrible smiley face here shows up, and I'm just gonna do this. You've seen all the other pieces, and so if we get all of them filled out, we go to a different level. The only thing different about the level is the color. Nothing changes, but I'll talk about that at the end. So how did I do that? Let's start with the goals. This is it. That's all the code for it. It's just cloning. That's all it is. It's cloning in math. Cloning in math. On the cat, I made some minor changes. Underneath the cat, I broadcasted a start. And I did that because when you go to a different level, I want these to reset. So I can broadcast the message start when I get enough points. I think I got it down here somewhere. So if points equals 5, set points back to 0, and we broadcast start, which is basically a restart, and it will reset these blocks up here. All right. So just like we did the cloning of these cars down here, we set up the clones here, and then we tell the clones how to behave right here. What we have is 5 clones, copied 5 times, and then we have this X value. Now we're doing that because we want to have these 5 goal posts, goal blocks, I guess. We want them to go to a certain location, and we want them to stay there and do nothing else. To do that, we have them go to this X coordinate. But so they're nice and evenly spaced, we do a little bit of math. So let me explain how this math works here. We set the value X at -300. Now -300 on the X is like off the screen here, but we change it here at by 100. And so the reason we started at -100 is because by the time this thing generates and by the time this code runs, the value has already been changed. And so this block underneath here, let's move those out of the way here. This block right here sits at negative 200. This one at negative 100, this one at 0, at 100 and 200. Okay, I can show you that actually. There's a fun little trick here if you want to check variables. You can have your clones say things. So it's going to say X value. So when I run it, you can see it'll tell you. Well, that sort of ruins the game, but if you want to check what the values are, there you go. So we set the X value below where we want it. We hide it, just like we do with almost all clones. We generate 5 of them. So it will create a clone, and then it will change the X value by 100. And then when it starts as a clone, it'll show up and it'll go to whatever the location is. So it starts at negative 300, but by the time this block runs, it's set to negative 200, which is that one, which I just showed you. Okay, the next clone, so it does this and then that, and then this and then that. So it goes up by 100 every time. So this is the generating part, and then this is the changing changing when the cat touches it. Okay, so there's other ways you can do this. I find this just an easy way of doing this sprite. So it's going to wait until the touching the cat, and it's important to note that if you use this waiting block, this stack of blocks here does nothing until the cat touches. Then it will broadcast message 1, which right here sends the cat back to the start. Because if I didn't have that, what happens is the cat touches the blue, or he's not touching the log and he dies. So the cat gets sent back to the start when he touches there, like instantly. And then it switches to the second costume, which is this silly face right here. Okay, and it changes a point, so it just tabulate points. And then it waits and it waits and it waits. And if points get to 5, which is greater than 4, they delete. So we get rid of all of our original clones. And then as I showed you here, way down here, if points are equal to 5, it broadcasts the message start, and it resets the whole thing. All right. So that's how I built those, generating 5 clones, changing the location with some math. All right. The next one is the turtles. Now, I've separated the turtles with this function, with this myblocks. You don't need to use this. It's just I find it easier to explain that when I've got it separated like this. Okay. So the way this works, again, I've cloned it. So I have 2 of them running, makes a clone of itself, and it has a pause of 3 seconds. You can see here that the 2 clones travel at different speeds. So when the turtle dives down, it slows down a little bit. I'll talk about that in a sec. So this generates the clone, and this is the behavior of the clone right here, and this is part of it. So it shows up, it switches to costume 2, which again is the first costume for some bizarre reason. It sets its log speed, because remember in the older videos this actually used to be a log. I didn't change that. Goes to start location, changes the size. This is all the same sort of setup from the log. All right. It's moving at this speed, and it regenerates when it gets to the end. Okay. This block here, this dive block, is all of this stuff here. Now, I could very easily just set it up like this, but I find it easier to explain this way. So you don't need to use these blocks. Okay. The important part of these diving turtles is that I've set it to be random. You can see on the screen here this dive number. it just is rapidly changing over and over again because of this. Set dive to random 1 to 75. It's just randomly flipping a coin, a 75-sided coin or die, whatever. And then only if the dive equals 2, and there's no reason for it to be 2, it's just any number. Pick any number. It will run the dive sequence. Okay, so if this were sitting in here instead of just like that, okay, it could be sitting in there. What happens, I've said this before, but it needs to be repeated. It does line by line. So it'll do this one, and then it will check to see the position, and then it will run this block, which is, again, all of this. It will set dive to a number, and then it will check to see if it's 2. If it's not, it just moves on to this again. It will check, it will set, it will check, it will move, it will check, it will set, it will check. And only when the number is 2, and you can see it down here, like the number gets set to 2 and it stays there for a bit, right? So that's what determines the randomness of the diving turtles. You can see here they just dove really quickly together. So when it dives, it repeats 7 times. Now this part here is very similar to our squished cat that we did earlier. You can see here that I've got 17 different costumes. And the reason for that is, okay, interruption there. Anyway, the reason we have 17 costumes is because to make the animation work, I've got sort of a duplicate. You can see it. You can't really see the white, but it works really well on the blue. Some of them are the same, and so it goes down to where the turtle is underwater, which is, it's just got some little white parts. So there's a bunch of them, and then it's the turtle coming back to the surface. So anyway, there's 17 of them. That's what you need to know. There's 17. You don't have to have 17. You can have a million if you want. So it repeats 17 times, next costume. And then it waits a little bit. I'll talk about that in a second. And then we have to put this move in, because otherwise, I'll show you an example. If I take that out, if I don't have that move in, watch what happens to the turtle when it dives into the water. It stops completely, because that's what we told it to do. Oh shoot, where did I put that? Right there. Okay. So the weighting is important for the costume, just like when we're doing the cat. If you don't have this short weight in here, it happens too quickly. All right. So again, line by line, it goes next costume, wait a tiny little bit, and then move. And the reason we have it as log speed times 2 is because it's normally moving at, what do we set log speed at? 4. But because we have this little weight in here, it slows down. So we have to speed it back up. Okay, so this process slows the animation down, so to make it appear proper, or at least better, because it's still got flaws, we do log speed times 2, which is just right here in the operators. Okay, so then we also have this costume number 9. This is how we make the cat die if it's on the on the turtles when it sinks. Okay, so if the costume, as it's changing, if the costume equals 9, we hide it for a very brief portion of a second and then show up. And this hide right here is what makes the turtles disappear for a fraction of a second, long enough for the cat to touch the blue and not be touching the log, which this one used to be log 2. So we've got it, turtles right there. So it's touching the turtles, but this little hide block here will leave the turtle standing on the blue without touching. So this is the part here that kills the cat if riding the turtle and it dives down. Okay, so it dives down, it waits a fraction of a second, and then it shows up again, and then we go back to our first costume here. All right, that's a fairly long-winded explanation. The shorter version is generate the clone, make 2 of them, wait a little bit. This is the behavior. This part is identical to these logs, which is just generate a couple and move over at a certain speed. Generate normally, and then the diving part is simply the dying cat animation. If you don't know what that is, go to the previous dying cat video. We have the randomness to it, which generates the time. Okay, so pick a random number. If it's 2, it could be 5, it could be 77. It's not going to work if it's 77. You can change these numbers too if you want it to be less frequent. Anyway, runs this code. It changes the costume, where there's 17 of them. Waits a little bit and then moves. We double the speed because it slows it down. Got to speed it back up. It disappears, so the cat dies. All right. That is most of it. There was the other part of the different levels. So we had the cat here, if points equal 5. I know in previous videos I said don't use equals, but the way the points are accumulated, it's never going to be more than 5 because it resets to 0 here. We have the ability to build different levels. What I have is I have 2 stages. They're just, one has pink stripes on it. All you would need to do is here we have set points to 0, switch backdrop, goal. What you could do then is have different variables for like car speed. So you could just make a new variable and have the car move. So this is car 1. I could just make a new variable called car speed 1 and set it to 4, and it'll play just as it is here. And then when we have our different level, we could simply here put set car speed 1 to 6 so it speeds up. Or I could generate 3 cars, or I could change this time with different variables. So there are different things you can do to make the game harder, to have different levels. But I want you to challenge yourself to do that. I think that if you've watched all 12 of these videos, that I've given you the tools that you need to build multi-levels. I've only built the one, but you can easily build multi-levels, and I challenge you to try it. So that ends our Frogger tutorials. What I am going to do is the future tutorials will use these same skills to build slightly different games. None of the other games will be as complete as this one, just sort of game ideas. All right, signing off on Frogger. Thanks for watching.